How many unique four-letter words can you create by rearranging the letters in the word book? This is our first situation where we have two identical items that we're arranging. Those O's are not distinct from one another. So how does one deal with that when we're dealing with counting? Well, we start off as we would with any four items, as we use our fundamental counting principle to rearrange those four items as follows: 4 times 3 times 2 times 1, which of course is 4 factorial, which is all we really needed to write at this point since we're using all four of those letters. And of course that 4, 3, 2, 1, remember that countdown is simply we have 4 letters for the first choice, and then once we use 1 we only have 3 remaining, and then we use that one, we have 2 remaining followed by 1 remaining. So as a starting point here, looks like we're going to have 24 possible ways we can arrange B-O-O-K. Let's think about maybe one situation in particular. What if we spelled out B-O-O-K in that exact order? And even though we can't distinguish those O's, I'm going to pretend that we can, because guess what? When you just go 4 factorial to get these 24 as an answer, it's assuming that you can distinguish all 4 items. Of course we can't. So if I were to spell book with the first O in the second position, or the first O in the third position, or I guess I should say O subscript 1, these spell the same word. Of course that's still going to be B-O-O-K. So why did we overcount? Well, of course, when you do 4 factorial, it's assuming, I can get that subscript back in there, there we go. It's assuming that you can somehow tell the difference between those O's, whether they're different colors or whether they're subscripts. And of course in this question they are completely indistinguishable from one another. So we've double counted just this one situation where we actually spelled out the word book. And if we flip that around in the reverse, maybe another situation of these 24, we could have K-O-O-B, a backwards book. And maybe I'll stick the subscripts on here because of course the 24 is including subscripts when it's counting them. And I would also quickly realize if I flip those O's in the middle and keep K and B of course in the same spot, how did we overcount that? Again, by a factor of 2, because there's exactly 2 ways we can rearrange those O's, which of course is 2 times 1 or 2 factorial. So we have to adjust our 24 to get the correct answer. We would start off with our 4 factorial, which of course is 24, and we would have to divide it by 2 factorial, which of course is also 2, to get our correct answer of 12. Now why is this 2 factorial here? Of course that's because we have exactly 2 identical letters. Of course, identical O's. Okay, so let's follow up with what we just did using a permutation generator to look at all those 24 outcomes that I didn't want to take the time to write out by hand. And don't worry too much about what a permutation is. It's just a fancy way of saying an arrangement where order matters. In this case, we have some duplication. So let's go back just a couple of steps before we consider the letters in the word book. If I want to look at the numbers 1, 2, 3, and 4, I can set n equal to 4 here, and of course that's going to give me all the permutations using the numbers 1, 2, 3, and 4, which if I click generate permutations, you will see all 4 factorial of those permutations there. And the same thing if I click on this option and say generate permutation using letters. That's just like our photo problem where we're figuring out how many ways to line up 4 people for a photograph, which is also 4 factorial. In both of these situations we have distinct items. We have no duplicate items. So let's get to duplicate items. So we'll use a custom list here. So the letters in the word book, and we're going to generate permutations, and we're still going to see 24 of those. But as I showed in a couple of examples, the written work, and good, we can fit them all on the screen. You can see book is there, and it's also 4 rows at the 4th row here. We can see duplication with the O's in the middle, O's at the beginning with B and K at the end, And that KOB business that I also showed you is there once. I don't see it the second time. There it is, sitting there in front of me as well. So for every one of these entries, you're guaranteed to have it duplicated somewhere else, and that's because of the 2 O's that are duplicate as well. So we have an option here where we can keep the distinct permutations, which gets rid of duplications, and that will divide those 24 by 2. And there are the 12 that we had in our final answer listed in front of you to make it a little bit more concrete. And feel free to play around. Of course, you have the website sitting there in front of you. This might be helpful to spend a few minutes playing around with this generator.